So let's get started. Best practices in green stormwater infrastructure. Something many of us are dealing with spring coming or spring here, hopefully. And we'll just turn to the next slide, Regina. I want to introduce you to our presenters. Dave and Mike are longtime partners of the T2 Center. They are also here at UConn. Dave Dickson is the director for the Center for Land Use Education and Research. And Mike Dietz is a water resources extension educator and also director of the Connecticut Institute of Water Resources. But they work together and have for years helping the towns with non-point education for municipal officials, land use education and research, stormwater. So we have them with us today. They're going to tell you a little bit more about themselves and talk a little bit about what's happening in Connecticut and some of the best practices and great case studies from towns around the state. I'll turn it over to you, Mike.
Thank you, Mary. Just had to find the unmute there. Got hidden when I was sharing. So thank you. Happy to be with you here this morning. And can you see the screen okay, Mary? Okay. And appreciate you using those much younger photos of Dave and I. Very flattering. Nice to see a younger version of each of us up there. So good morning, everybody. Thank you for spending a few minutes with us this morning. As Mary said, we are longtime collaborators with the T2 Center and really support what they all do there and are very happy to be involved in this, to chat with you this morning. So if you have a question about something that Dave or I are talking about that's very specific to that slide, please go ahead and raise your hand and Mary will help coordinate that with me. Other questions we'll hold till the end, just general stuff, and we'll have plenty of time to answer that for you. So I'm going to just go through a little bit of a history here at UConn as to how we've implemented some of these green stormwater practices. I'm also going to pull in some examples from outside to help illustrate some points. And then Dave will talk about some other topics that are relevant to this too, that other towns have been working on, and some upcoming opportunities. So just one propaganda slide before we get started. So as Mary mentioned, Dave is the director of CLEAR. I'm also part of CLEAR. CLEAR is the Center for Land Use Education and Research. And our mission is to provide research, tools, information, and assistance to communities and other audiences in support of better land use decisions, healthier natural resources, and more resilient communities. So our website has lots of great information on there. There are lots of recorded webinars that we've done that cover various topics from green stormwater infrastructure to land use. We have a robust land use training program and also a lot of GIS resources as well and training that's available in there. So we encourage you to check that out if you're interested. Before we get started, we have a quick survey for you here. Let me make sure I can get back to it here. Looks like I've already messed it up. Here we go. Hold on. And there we go. So if you could do that little QR code there and answer those two questions about what you do and your familiarity with green stormwater infrastructure, that will help us a little bit in how we frame this conversation today. Give you a second there. Okay, so got a few trickling in here so far. We've got a lot of other. Interesting.
Something that might help with the others, you should type in what is your otherness.
Yeah, and I can see that.
If you work at UConn or you're
Yes, thank you, Mary.
Sure.
So I think I can see that in the responses, but I don't know if I can present that.
No, but it won't let you finish your survey until you
That's
fill
right.
that in.
Oh, jeez, it's all right. All right, so we got 10 in, and so far everybody is other. So maybe just for our purposes, if you could just drop in the chat what your current position is, that'll be helpful. Mary and Regina can take a
Yes,
look at that.
perfect.
And the next question was, what is your level of familiarity with low impact development or green stormwater infrastructure? So we've got a couple of toddlers in here, which is fine. Let's quite a few folks that are kind of familiar but don't want to be asked any questions, which is also great and pretty familiar. And then a couple of experts, which is wonderful. So I will turn the presentation over to you if you would like right now. We're happy to do that and go on the fly with anyone else who would like to chat. All right, so this is very helpful for us, and I will move forward with my next slide here, if I can get it. All right, so just to set the stage, just one background slide here before we introduce the topic of low impact development. So the reason why we're talking about this, why green stormwater infrastructure is something that is a current need and things that have been in this realm for about 30 years now, is because of known impacts to the hydrologic cycle as a result of our development on the landscape. So there are well-documented impacts to the amount of water quantity that flows off the landscape as a result of all the impervious surfaces that we add, our buildings, roads, parking lots, etc. That increases the peak flow rate. It also increases the volume of runoff that comes off of these surfaces. And there are known documented impacts to the water quality as well. So nutrients, bacteria, sediment, other toxics that are in that stormwater runoff create problems in those receiving waters downstream of urban areas, suburban areas, even slightly developed areas. So this is all known, documented stuff in the scientific literature. And that's really the reason why low impact development began down in Maryland in the 1990s. Just like we have the Long Island Sound, Maryland has the Chesapeake Bay. It's a very economically important and culturally important body of water to them. They had issues with the bay and specifically with nutrients. And they knew that the development and agriculture in that watershed were causing problems. They did not want to shut down development in the watershed. They knew that wasn't really going to be practical. So they came up with this approach called low impact development that allowed them to develop on the landscape while still making that landscape function as it did before that development was there. So trying to replicate some of the pre-development hydrology is the term that's used for sites. So trying to replicate the pre-development hydrology of that site before it was developed. So the practices that are in that guide, that's really what gets most of the focus. The original low impact development approach had a lot of work that you were supposed to do before development began. A lot of planning and thought that went into how you developed a site. These days, it seems that most of the focus gets put on the practices themselves. And especially if we're doing a retrofit, like if we have an existing developed area, we're not developing that. So these retrofits are where the practices like permeable pavements, rain gardens, bioretention, green roofs, etc., come into play. So that's mostly what we'll focus on here today. So first, we'll start it off with rain gardens or bioretention. So this is a depression in the landscape that's designed to collect and infiltrate stormwater, trying to replicate how this system functioned before all these paved surfaces were on it. And besides performing this function, they also have an added benefit of being aesthetically pleasing. They're nice to look at. So there are other ways to get water into the ground. You've probably heard of dry wells or subsurface infiltration, those sorts of things. But rain gardens provide an aesthetic benefit and also an ecosystem benefit, which we'll talk about as well. So here at UConn, our first foray into the rain garden or bioretention worlds was in 2004. And I'll just clarify one thing on terminology here. They're really the same idea, the same concept, rain gardens and bioretention areas. The main difference that seems to have come into practice in the literature is when we talk about bioretention, it typically is something that will involve more engineering. There are overflow structures. There are likely under drains that are tied into the stormwater system. Their practices, these are pieces of those systems that are in place in mostly densely developed areas to avoid excessive surface ponding and to make sure that we're not flooding any areas, if the system doesn't function as expected. So it's really the same idea. Collect that stormwater, let it sink into the ground. There's just a little more engineering that goes into a bioretention area. So in 2004, we put in our first bioretention up at the Towers dorms. So the concept was fairly new at the time. And some of the folks that were involved with this, I was actually here in graduate school. My advisor played a big role in this project, as did others who were involved with the Jordan Cove project, which is another big low impact development project that happened in the 1990s through the early 2000s here in the state. And we used some lessons learned from that project to help guide the installation of this first bioretention here at UConn. So this was 2004. In the past 20, 21 years, we now have, our last count was over 65 individual practices, both rain gardens, permeable pavements, and green roofs installed here at the University of Connecticut. So we've made tremendous progress in the past 20 years and are really a nice living laboratory of an example of these green stormwater features. So shortly after that first installation, it was fairly slow progress in those early years, I would say. We had some large new buildings that got installed over near the Student Union and the library. If anybody went to UConn or has come up to UConn, you've probably walked by these. So in this period of time, there was a big focus on this large linear engineered design that functions quite well. So these are pretty deep and large systems that handle a lot of runoff from the roofs of those buildings. This was early on, this picture. In recent years, you'll see a picture of Dave standing next to one later on in this presentation. They have grown up substantially and have created a nice little mini ecosystem next to this building, but they still have that long linear feel to them. And, you know, you can, again, functionally, they're still doing the same thing, but it's a different aesthetic. Throughout this time period, there have also been some small scale rain gardens that have gone in. Here's one example. This is a project that I worked on with some students in the Soil and Water Conservation Society here at UConn. They wanted to install a rain garden, so we picked this site next to one of the dorm buildings here on the ag side of campus. So we disconnected this downspout that was coming down the building and directed that water into a small rain garden. Here you can see it fully grown out with some nice purple coneflower or echinacea in there. And this one is performing quite well and has continued to do well over the years. This is an example. We use this one quite a bit as an example of a residential scale rain garden. This is what someone might install at their home, about the size and the scale of that. In recent years, in the past 2.5 or so years, we've had some changes in the approach that we use. And I just remembered there was another example of this, a smaller example. And if you end up coming on a tour with me at some point, I'll point this one out. And if we have time at the end, I can pull up a picture of it too and show you. But we've moved away from this long linear form of the bioretentions that we're installing. So this is the new Science One building that went in. I guess it was about 2 years ago now, just about 2.5 years ago now, over on the west side of campus. So you can see right away that this really looks like a naturalized area, and that was the goal. The designers of this building basically built this bioretention thinking about how it would look for students as they sat inside this lower level of the building and were looking outside. So to look at it in a rainstorm, you would see water moving through this whole system, basically like a river system. And it really has that nice organic feel to it. Again, even though it's performing functionally the same way the other ones, those linear, long linear deep structures do, this one just has a much softer feel and fits nicer into the site, into the surrounding area. There's also some nice signage here illustrating. You can see on the sign there that long sinuous form, really designed to look and feel like a dry riverbed. And during a storm, it will fill up and function basically like a river system would. We've also continued to do some of the smaller scale rain gardens. So again, this is another student-led effort that happened just exactly a year ago now. So if you've been to the UConn Dairy Bar, just outside of the Dairy Bar, we identified another site for this group of students, and they got some funding on their own to cover the cost of the plantings. They coordinated a bunch of students to come. I helped out with some of the prep work and getting the site ready, getting the drainage, the pipes from this building, directing that runoff over to the site. But it was a great day having students out here. This was the finished garden last April. Over the summer, this one took off and has done extremely well. Here you can see the monarchs on the garden, on the plants here, on the coneflower, and then we have the monarch larva later in the summer. So this really doing a nice job for the pollinators. Aesthetically, a nice thing to look at over there by the dairy bar. And the students that designed the plantings thought about how the blooms would look throughout the course of a year. And here we have it into November with these beautiful asters blooming right up into late in the season. So some nice thought put into this, and just a real good demonstration of the season, multi-season bloom and impact that these things can have aesthetically. Now, just in case some of you are here and you're thinking about the slides that I've shown and you're feeling that I'm biasing and showing just lots of nice, pretty pictures of how nice these things are working. And this, you might be thinking, yes, those things look great, but our downtown is too dense and there are lots of utilities in the way and the engineering is expensive. And there are a lot of other reasons that we've heard, and some of these are valid. Yes, I'm not going to deny that it's hard to do these things in a downtown area. There are utilities in the way. It's a complicated process. But I will tell you that in some of our big cities here in the state, in New Haven, for example, these are not our projects. These are some folks that we know who have presented to us and to T2 Center on some of the work that they're doing. So there's a major bioswale effort underway in New Haven. They've got more than 250 of them installed, tucked in between the street and the sidewalk in many locations. Here they've done some nice traffic calming. So again, just to recognize Giovanni Zinn, who's the engineer in the city, and Don Henning, the assistant city engineer. Here's an example on Clifton Avenue, a before picture of this intersection. There's the after. So you'll note on the sides of this intersection, these mini bump outs that have the bioretention areas in there. I'm going to go back up so you can see it. There's before, there's after. So as you know, many of you are well aware of this, when you restrict the size of the road like that, it has a traffic calming effect. So this is a great example of having multiple benefits. We're traffic calming, we're slowing people down, making them aware of this pedestrian crosswalk here. Extra signage was added, but this is a multifunctional site that slows people down, gets water into these little pocket bioretention areas, and reduces the amount of runoff. New Haven is a combined sewer city, so they are actively trying to separate those systems and direct that runoff into the ground rather into that combined sewer system. Down in Washington, D.C., again, very densely developed. I've happened upon some of these things just walking to the hotel where I go to for an annual meeting every year. So again, in basically a concrete jungle here, we've got bioretention areas that they installed between the street and the building. Here's another example, again, very heavily developed downtown areas where they've actually integrated art features into the landscape to try to draw people in and make them inquire about what's going on. They have really nice signage in these to give people information about what this is. So where there's a will, there's a way. I'm not going to tell you that these things were cheap to do, cost a lot of money to do it, but they're doing it in heavily developed areas, and people are looking at it and learning about it at the same time. This is another example right next to the hotel where I go. This is a little skinny bioretention area that they installed. This is a bike pathway here that has a permeable pavement on it, which we'll get to next. And over at the wharf, again, this is where I stay for this conference that I go to. This area was developing very, very rapidly over the past few years. And in the midst of that big development that they're doing, they're integrating these really nice big bioretention areas and creating these little pocket parks in this heavily developed area. It's very well used. I was here in February. There were people sitting out here and utilizing it even in the off season. There's another example. You can see the bikes parked there. So again, this doesn't look the best because it's the winter there, but you can see the nice winterberry if you recognize that, those shrubs. So providing some wildlife benefit in addition to the stormwater function of this site. So we'll switch to permeable pavements now. So there are several permeable options that you can use that are alternatives to traditional asphalt and concrete. Not every product is suitable for every application. That's a key point. I'm going to give you some examples of some that did not work so well, or one. If we have time, I'll bring up another one. So we've tried pretty much everything here on the UConn campus, and we've learned some good lessons on this. So we've had very good luck with the permeable interlocking concrete pavers, or PICPs. So right next to this, the McHugh Hall building, where one of those long linear bioretentions were installed, This is again by the Student Union and near the library. These blocks on the right are those PICPs. The left is a traditional asphalt sidewalk. You can see water sheeting off of this in a rain event, and nothing is being generated and not running off on the PICP site. So this particular installation has worked very, very well. This is another great example of the PICPs over on Hillside Road. There's some dome in the background there. They play some sport here at the university. I'm really not sure what it is. Dave can explain that more. He's our sports guy. He'll fill you in on that. But these are what they look like if you look up close. So the brick, this is actually, to be technically correct, this is actually a brick paver, not a concrete paver. That does have some advantages in certain applications where they might get a lot of salt. For the engineers in the group, you know that salt and concrete generally don't mix well. So these are more robust and resistant to any salt damage that might happen in the winter. So the water doesn't pass through the paver itself, it passes through the gaps in between. And there's a special base underneath these pavers that's designed to allow that water to go in and sink down into the ground underneath. That's a key feature of all of these installations. Over at that Science 1 building where we have that large organic form bioretention, this is a utility fire access area behind that building that has these grid pavers. You may have seen these. I've actually seen these quite a bit in the pull-offs, like where Eversource had some utility access areas on the side of the road. They like to use this particular product. So again, permeable base underneath. These particular ones can handle heavy weight loading, so fire trucks can access this. So again, just dispelling some of the myths that might be out there. I'll also mention here the people often ask about the winter performance of all of these pavements. And we have shown, and the literature supports this, that they actually do better in the winter than traditional pavements because of that permeable base underneath and the fact that water can't pond on the surface of these products and refreeze during the night and have that black ice forming. The permeable structures actually perform better through the winter and don't frost heave and crack. This is an example, and good question, David, about the ADA compliance. I believe that most of these products are ADA compliant. That we certainly could not put anything in here at the university that was not. So yes, that's a very good question. Early on, this was, I want to say this was in the 2006 timeframe. We installed this is a plastic grid structure. And in certain applications, these can work just fine. This was supposed to be just a rarely used utility access for the training center over here, the football training center. So it had the permeable base underneath. These can either get filled with crushed stone or with soil that gets planted with turf. So there are other applications in low traffic areas where that can work. Unfortunately, this ended up being an area that got a lot more car traffic, a lot of pulling in and turning, and in the winter, they started to get beat up from cars and the plows started damaging them. So this did not work well on the UConn campus in a high traffic area. So that was a lesson learned for us. But again, when I'm down in DC, this is at the Botanic Garden. These products have worked extremely well down there. This is, again, you can roll a wheelchair right over this particular product. Works great in an area that you're not plowing in the winter where you've just got pedestrian access. You can drive vehicles on them. I have seen low traffic vehicle access work, but my personal opinion is the best application for these is pedestrian access areas. Permeable asphalt is another product that we've had really good success with here at the university. This is a variation of asphalt that leaves the sand out of the mix. So it's just got the stone aggregate and an asphalt binder. The nice advantage of these is it goes down with the same equipment as regular asphalt. So that makes it a lot easier to install than some other particular products that we can talk about if I have time. And the cost is only slightly more than traditional asphalt at this point, which is another nice advantage. So 2009, we had a large parking lot up at Towers go in with this product. This lot has done extremely well if you look at it today. So what are we, 16 years later, right? 19, yeah, like 16, 17 years later, and this thing doesn't have a crack in it, doesn't have a frost heave. Show me a traditional asphalt lot that's 16 years old and doesn't have a frost heave in it or a crack. I would be shocked. So that permeable base has proven that the longevity of these products is a side advantage of this. The permeability, if you're maintaining it, which we'll get to, they can continue to do well. That's what the product looks like. Just a little bit rougher appearance if you look at it, but if you're not looking specifically at it, you probably wouldn't notice it. And then again, at that Science 1, have a nice application of the permeable asphalt in the parking stalls. The center was traditional asphalt, just done this way to save a bit of money. So maintenance. I know many of you are very concerned about maintenance. You probably do maintenance as part of your work. I always like to talk about maintenance of permeable pavements here, like going to the dentist. I don't know anyone that if I ask them, do you like to go get your teeth cleaned at the dentist? This guy's smiling here in a nice picture that the dentist posted. Nobody really wants to go get their teeth cleaned. It's not a pleasant process in general, but it's not that bad in general. So the reason why we go to get our teeth clean is so we can avoid having things like root canals. So I'm very sorry if any of you are holding your jaw right now and having a flashback to your last root canal at the dentist, if you saw someone looking at you with a drill trying to dive into your mouth like this. So you are well aware of the reasons why we do maintenance. It's to save money in the long run. If you take care of something in the short run, it will last longer. So maintenance, the problem is maintenance isn't sexy. It doesn't make for great photo opportunities. Not like the ribbon cutting at the rain garden when it gets installed. Everybody's excited on that first day. But the regular inspection of these features is critical to prevent costly repairs down the road. So here's some examples, just how the permeable pavements, the maintenance on this is to suck out that sand that accumulates in there. You're not supposed to sand them in the winter, but sand does track in. There's windblown dust that can accumulate in these things. And the recommended maintenance is to use a regenerative air vacuum sweeper to pull that sediment out, not a regular street sweeper. Here's what the maintenance or this same pavement looked like after maintenance, but this was not with a regular regenerative air sweeper. Because we neglected it, we needed to have a special equipment come in that blasts high pressure water and sucks that pavement clean. So again, this stuff had to be brought in and it was very costly because we were not maintaining it on a regular basis. So I'm not going to play this little video here just in the interest of time. We can come back to it if you'd like, if anybody wants to see that. Here's another example of how maintenance was neglected. So that was that rain garden in 2004 that went in. In 2014, it looked like this. So there was a well-worn footpath between the dormitory and the dining hall in the distance there. So the students take the shortest distance between 2 points. It's human nature. What that resulted in was water entering this bioretention and going right out the other side and into a catch basin outside of the treatment unit. So this needed to be remedied. So we did some surgery here and fixed that issue with some students. And you can see how big that tree is and how much this thing has grown over the years. So it's basically like bypass surgery. If you're not taking care of your body, you need bypass surgery. So that's what happened here. And so I'm going to turn it over to Dave to talk about a few other examples here.
Great. Thanks, Mike. Yeah, and just to give you some very local examples, this is not just on the UConn campus where this stuff is happening, although it's sort of really, I mean, the UConn campus is probably one of the premier places in New England to see all these practices because there's such a high concentration of them. So I really encourage you, if you get a chance, to sort of walk around. And we're actually working on a self-guided walking tour. So if Mike or I aren't available to lead you around, we're going to have a self-guided walking tour where you can just sort of walk through on your own with your phone, and there'll be videos of Mike that pop up telling you some of the stuff that he just told you. So one of the things we want to talk to you about is the town of Colchester is a really good example of trying to get some of this stuff in place. And so back in 2015, I don't know if anybody on the call is from Colchester. So if you are and you want to update any of the stuff that I have, please feel free to jump in. But as I understand it, in 2015, they updated their zoning regulations and they put in basically a permeable asphalt or permeable surface requirement for their parking lots. Oh, good. The town planner is on from Colchester. So after I talk, you can sort of correct all the things that I say wrong or update us if you want to. And as I understand it, if it's still in place, no more than 75% of the parking lot can be made of impervious cover, right? And so developer has to either come up with a plan for grass parking lots or use pervious materials. for overflow parking and that type of thing, and have a maintenance plan for how that's going to be maintained, as Mike just talked about how important that is, particularly with permeable asphalt surfaces. Next slide, Mike. And so the results of this is, as the last time we talked to the folks in Colchester, and maybe that they can update me, there were 10 new private installations of pervious pavement in town. There were 3 projects at local schools. The last time we talked to them, they were sort of in process. I don't know if they're completed now. And it was reported to us that the prices have been coming down. Because once they started requiring this and more developers were putting it in, there was a local supplier who began supplying the pervious asphalt. And then the local contractors started to get experience in doing it. And so they knew how to do it right. I mean, the first time we did it on UConn, there was all kinds of problems with transporting the stuff to the site. The site that Mike talked about is really old and has no frost heaves. And so as the town started requiring the stuff, it became a little bit more routine and built into sort of the infrastructure. So it became a little bit easier to do. And so, and the prices came down. I think the last I had heard, it was, and this probably has changed. Regular asphalt was like $100 a ton for folks, at least in the Colchester area, and the permeable stuff was 140 a ton. So it's still more expensive, but not as expensive. It used to be double or more for the pervious asphalt. So they have seen that price come down. Next slide, Mike. Another example that some communities have used is tree box filters. And these look just like a regular catch basin, but there's a tree in it, right? And so that tree helps to suck up the excess stormwater, and anything the tree doesn't suck up goes back into the ground and infiltrates in. So you put these in, often right next to a catch basin in town. They're great for small spaces, great for like a downtown or a Main Street area. Don't require a bunch of excavation, like a larger bioretention might. And they can capture large amounts of stormwater. An example of this being used effectively is in East Lyme. Next slide, Mike. Where in East Lyme, they partnered with, that was just a sort of a schematic, I forgot that was in there, of what the sort of tree box filter looks like. But in East Lyme, they partnered with the Connecticut Conservation District, and they got some funding from DEP. And Vic Benny, who used to be the town engineer in East Lyme. I don't know if we have anybody from East Lyme on the call, but feel free to give a shout out, and we'd love to get any updates. But they installed 21 of what they called tree wells, which they designed in-house. Vic and his team designed these using granite curbing, right, for the sides of the well. And they filled the bottom of it with stone, and then engineered soil, and then stone on top. And then they put trees, and in some places they put like grasses in them along the streets in sort of their downtown area. And they were able to put these in for just like $3,000 each, using their own public works folks to install them and cut the granite and things like that. They were able to do it fairly cheaply. So it doesn't have to be super expensive either. Okay, next slide, Mike. And just a quick note on MS4, which I know is a dirty word or dirty phrase for many people, doesn't always engender. That's what's driving a lot of this, though, right now, is in 2017, DEP updated the municipal separate storm sewer system regulation and had a huge focus on these practices, right, and encouraged towns to do it. So towns had to go through the regulations and remove barriers to their use. They had to update the regulations to have new developments consider the use of these practices before they consider traditional methods. And the biggie that a lot of people have struggled with is they wanted you to look at existing development and disconnect 1% of impervious cover per year. And that was starting in 2020. And so every year since then, and going forward, right now, towns are supposed to be disconnecting 1% of their impervious cover per year, having it flow into the ground instead and infiltrate in. So that's a huge ask, and that's going to require use of a lot of these practices to be able to meet that requirement. And I will say that there's a new version of the stormwater permit that just came out. They still have that 1% requirement in there, or they've made it a little bit more flexible, where you can sort of partially meet it as opposed to fully meet it. And that's out for comment right now. So if you're involved in MS4 and you want to look and see what they're proposing for the next version and provide some comments on it, this is the time to do that. And you can go to the Deeps website to find that. Next slide, Mike. The other thing I wanted to say is we do have actually through Sustainable CT, they asked us to organize a Green Stormwater Infrastructure tour on campus as part of, well, yesterday was Earth Day, but they're doing it as Earth Month. So if any of you are interested in taking the tour and are available this Monday at 1 p.m., you can go to this link and sign up for the tour. There's still some spots left. It's about like a 1 mile walk, maybe a little bit more, that will take you on, and Mike and I will give you sort of information. You can sort of see these practices that we've been showing you pictures of up close. Next slide, Mike. Do you want to do the conclusions, Mike, or do you want me to? Okay, so as you can see from the slide, and there's lots of great examples out there. It's not just on campus. It's a lot of communities are doing it, and they're finding innovative ways to do this at low cost. And the maintenance piece is the key part. Figuring out how to sort of build in the maintenance is hard, but we have to do maintenance with traditional gray infrastructure as well. So it's just a matter of sort of figuring out what those systems are and learning from other examples and building on those. And these don't work everywhere. And not every product works everywhere. So you have to choose the right product for the right situation. You know, if you have just like a walking path, you can do things that you wouldn't want to do on a heavily used parking lot or driveway, as Mike demonstrated with the football complex. And you know, maintenance is always critical. So we'll stop there. We want to hear your questions. So fire at us. And if the folks from Colchester, or I didn't see if there's anybody from East Lyme, want to update us on their experiences, that would be great as well.
So Nicole did share in the chat that they also utilize pervious paving in the senior center parking lot, which just opened this past winter. And she noted that Sal Tassone, who's a longtime town engineer in Colchester, is a great resource for that. Nicole, did you want to share anything else or talk about future projects that might be coming up in Colchester? I don't want to put you on the spot, but I like that you're here. And I don't think we have anybody from East Lyme.
David Castro asked a question here about the design side. Which one did you mean, David? Slide right before the East Lyme slide. That one.
Yeah, I think that, yeah.
Okay.
So
Any
we'll
other
make sure
questions?
that we share this too. I'll get a copy of this and we'll send it as in the follow-up email, just so that folks have this spec. And I'll touch base with East Lyme just to see who the best person to talk to, the current person, because Vic is not with East Lyme anymore. So we'll find out who might know best about these that's still there, and see if they'd be willing to be a resource for us, just to talk a little bit more about their experience and some of the long-term, you know, how is it going several years later? Are they continuing to do that, or have they tweaked it at all?
Yes, thanks, Mary.
Sure.
David, I'll note on here, that particular design that one's called Storm Tree. That's one of the proprietary products that's out there. We actually tested a few of these here at UConn as a small project, but the bigger one is called Filterra. That's another very well-known, you know, proprietary product. I'm not sure what the Storm Tree cost is right now. The Filterra ones, they were like $10,000 or $12,000 a unit. So this was the main motivator for Vic to do this on their own, the one that Dave described. And you know, they saved a substantial amount of money just doing them themselves.
Yeah.
And I think that Vic, if anybody's interested, I think Vic shared his design and his sort of schematic that he used with us. And I think that's available on our website. I can share that with you, Mary, to send around as well.
Sure. Yeah.
Jim is asking about weeds growing in the joints of the permeable pavers. We really haven't seen that as a big issue here. So it's not really soil in there. It's just either like a chip stone, or in some cases it's nothing at all. Some of them just had a gap where they had a structure underneath it. So we really haven't seen that as a problem here. And again, if they're being maintained on a fairly regular basis, that stuff would be getting sucked out anyway.
We also asked, had somebody ask if we could share a planting list for those rain gardens.
Yes, I
Um,
did post our website for that and
Perfect.
also our app.
Great. Jen Hung, I see that your hand is raised. Go ahead and unmute and ask your
Yeah,
question.
thank you. I'm the traffic engineer in state of Stanford. I have a quick question about the slide right after this one, the tree box. If you can go to the next slide. There's one before this, or maybe the one after this one. No, before. Go back. Go back. Yeah, this one. Yes.
Yep,
So
that's
this
a filtering. That's
yeah, that's a
filtering.
filter. So
Yep.
if so in downtown Stanford, we plant like much taller trees.
Mhm.
So with the much larger root, so the root would break the tree crate, the filter, and it becomes
These actually, they have an open, most of these have an open bottom, so the roots can go out underneath and go into the soil below.
okay. So
Yep.
well, but do you have a product like for a lot of this tree box in Stanford, it just cracks over time, and it just the surface part is not even, so it
So,
becomes a
oh, so
chipping.
you guys have some installed? Is that what you're saying down there? You have?
Yes, yeah,
Okay, sorry.
yeah, and then it becomes a tripping hazard. So we switched from this product to flex pave.
Uh-huh.
Yeah, what is your experience with FlexPave? And the issue with FlexPave is, for the FlexPave, we have the opening for trees, and it's typically small. With and once the opening is too small, the tree won't grow like tall and large. They don't look very healthy. So
Yeah.
we struggle with different approach, with permeable and trees and tree paste and stuff like that. So what is your experience or good successful example for downtown streets area?
So the Flexi Pave, just for those who haven't heard of that product before, it's a chopped up recycled tires. So basically
Yeah.
they take old tires, chop it up into little products, and then have some sort of binder that holds it together. It's often used in parks or other places like that where you want a soft surface for kids. It's not great for high traffic, so it's typically not used where you've got vehicles. It's only for foot traffic. So
Yeah.
it can work very well in those applications. There are some variations where they mix some aggregate in too. We actually had a demonstration of that here at UConn, that in a parking stall where it had both of those products and it worked very nicely. But as far as your question and your application in the downtown areas, I guess the only one that I can speak best to are the examples that we have in the stores downtown. They've planted trees in there that won't get super big, and the tree filters that they installed are fine. They have the open bottom so the roots can go out, and the trees will just basically fill the space and go out if the roots can go out. But the trees, they haven't planted trees in there that will get 40, 50 feet tall. So I think that may be the best approach, is to try to find a tree that is going to be good for your site. And that's a little outside of my area of expertise. I don't want to give you any specific examples on that because I don't have any. You may want to talk with an urban forester about something like that. I think that's probably what I would recommend.
Okay, thank you.
Yep.
Any other questions? Checking. So oh, go ahead. Yes.
No, I was going to ask a question for the people here. I know sort of the things that don't work often have sort of a longer lifetime than the things that do work. And so I'm just wondering if people have tried some of this stuff and it sort of maybe hasn't gone well and why that hasn't worked. I don't know. I just figured I'd throw a question to the group and see.
Everybody's shy.
Which is fine. And people can just post it in the chat if they want to, but if you had a question, Donna, go ahead. Mary, go ahead.
Yeah, so that was something actually I was gonna just start the discussion on, you know, lessons learned from those who have tried. I think we kind of started down that way with Jen Hung talking about, you know, if you don't have the right tree and the right treatment, you can end up with, you know, damage, the winter maintenance and using sand salt on the pervious pavements. That's always a quick lesson learned, I think. With many of us switching to all salt, obviously less, but still an issue. And that maintenance, I think that maintenance point that you made was really good. But, you know, are there any resources that have been developed, kind of a then and now, a look back and a lessons learned focus?
From us, Mary, is that what you're asking?
Yeah,
I don't know that we've put anything together formal on that. That's a good point. I'm sure
Yeah.
that there are things out there. You know, I did like a literature review that we published a long time ago. This goes way back to 2007. This was more at the performance and like what was working well, what wasn't working well, where were the gaps, knowledge gaps at that point. But I don't know as far as like the practical aspects if someone's published something like that. That's a good question.
sure. And some of our more rural towns, I am interested to know, you know, why you joined us today, what you're thinking about, possibly, um, you know, using some of the GSI for. Are there particular projects or areas of your towns that you're trying to address? And Mike and Dave, do you have, is there a trend with when towns are first getting started? Places where they kind of tend to try something out and then expand from there?
Yeah, we've seen that the rain gardens tend to be the gateway drug. It's an easy first installation. You can do them on a small scale, you know, like those ones that I showed from the dorm and like even the dairy bar. Those are pretty small and pretty easy to do. They get, you know, they have multiple benefits as I talked about. So that we see that a lot. Rain gardens are typically the first foray.
Okay, all right. Dave shared a lot of ledge, yeah. Um, any ways to help with the stormwater infrastructure? Yeah, when you can't, there's nowhere for the water to go. We have that up my way up as well.
Eric, yeah, high water table, that's a real challenge. And, you know, that's like one of the two top rain garden killers is like having groundwater right below the surface. So I generally recommend not to put it in if you've got, you know, really, really high groundwater.
Are there other treatments that might be useful? Other
In a scenario like
techniques?
that,
Yeah,
maybe water harvesting, you know, if you can do some large scale water harvesting. You know, we've seen some examples from our colleague down in New Jersey who's done a lot of this. They have some really large water harvesting off of buildings and then they use it to water a community garden. So, you know, trying to put that water to use.
like giant rain barrels.
Yeah, yeah. It was basically a big corrugated metal tank that they used. It was pretty interesting.
All right. Oh, let's see. Oh,
Nicole, about regulations about water harvesting in general, it's as far as I know, nobody has any regulations preventing it. It's very different out west. It was something I learned when I lived out there that water law is very different out there. And there were states that you know, technically speaking, you couldn't put a rain barrel on your own house. It was considered a taking of water. And many have changed those regulations since then to address that issue. But yeah, as far as I know, nobody in New England has any laws preventing that. Good question.
all right. All right. Any other questions for our friends from Clear? Or any other conversation that you want to have regarding stormwater or low impact development?
I'll just add, there's a question in there about looking for more help with MS4. We have a website dedicated to MS4, at least the current version of the permit. Deep sort of, gave us some money to sort of develop this. We don't think that's happening with the new permit. So, we're not going to be updating it or anything like that for the new one, but I will post that link in the, oh, you already did, Mike.
Got
Thanks.
it, Dave. Yep.
That's the link to our MS4 support site. So it goes through all the different requirements and then tries to provide resources to make it, I wouldn't want to say easier, but to make it a little bit more palatable, maybe.
All right, and they have the listserv too. Can they sign up for the listserv off that site?
Yep. The listserv is still on that site. But like I said, we're not maintaining that anymore because we're not getting funding to continue to provide that support. So,
Got it.
soon that will be mothballed, that site.
Okay. All right. Well, if we don't have any other questions, I want to thank you so much for joining us today. I'm actually going to share my screen because we have a nice QR code for you to use in giving us some feedback. It wants to, there we go. Giving us some feedback on today's webinar and also giving us some ideas for future coffee and conversations. I want to thank Dave and Mike for their time today. We really appreciate our partnership with them, and we'll be doing some more with them in the future, especially as we see what the changes are to the MS4 permit. I'm sure we will be reaching back out and getting them involved to help us understand what some of those changes are and what those impacts will be for the towns. And thank you all for joining us. And I appreciate your time. So we're just going to leave this up. There's also a link in the chat if you prefer to access the evaluation that way. But if you don't have any
Thanks,
other
Mary.
questions, yes, thank you so much. Really
Our
appreciate your
pleasure.
time.
Always great to chat with you.
Thank you.
Thank you, Regina.
And thank you for wearing your orange. Remember, everybody, it's Go
problem.
Orange Day. It is National Work Zone Awareness Week. And we're celebrating Go Orange Day today here at the T2 Center. We hope you all are doing that in your towns as well.
Thank you.
All right. Thank you.